Okay, so this video is to finish section 4.1 that we started today. So I'm going to start here, just for a little recap of what we did. So the last thing we did in class was we graphed this. So first we graphed the sine parent function, 0, pi over 2, pi, 3 pi over 2, and 2 pi. And we used the y values around the circle. Sine at 0 is 0, 1, 0, -1, 0. Here was our parent function. However, in the next equation right here, we have a 2. And the 2 is next to the theta, so it's going to affect my thetas. And that 2 is a girly liar. And instead of multiplying by 2, we're going to divide by 2, which is the same thing as multiplying by a half. 0 divided by 2 is 0. A half, or pi over 2 divided by 2, is a pi over 4. A whole divided by 2 is a pi over 2. 3 halves divided by 2 is 3/4. Or another way to think about it is $1.50, or 1.5 divided by 2 is 75 cents. And then 2 pi divided by 2 is pi. So 0, pi over 4 is halfway between 0 and pi over 2. At pi over 2, we're back at 0. At 3 pi over 4, we're at -1. So you can see that this thing is horizontally compressed or moved in. If I were to keep going, I can fit 2 full cycles in. 2 full cycles in here, where normally I'd only have 1. So up here, when is it a stretch? When the absolute value of v is actually less than 1. And in the case we just had, the absolute value of b was greater than 1, so it was a horizontal compression or shrink. If we make b negative, we are making all the x values negative, which means it would be a reflection across the x-axis. So let's try another problem. So let's try this one. So this time, just beware, it's cosine that I'm graphing. So the angles are going to stay exactly the same. Zero, pi over 2, pi, 3 pi over 2, and 2 pi. But this time, I'm going to put parentheses, or quotes. It's x. It's still going to go on my y-axis, but I want the x value. So the x value at 0 is 1. The x value at pi over 2 is 0. The x value, because I'm doing cosine, at pi is -1. The x value at 3 pi over 2 is 0, and then back to 1 again. In this problem, I have this right here, 2/3. It says multiply by 2/3, so we're really going to divide by 2/3. And if you think about that for a second, if I have a divided by 2/3, you keep, change the multiply, and flip. So I need to really multiply by 3 over 2. So 0 times anything is 0. That's pi over 2, the 1/2. It's a 1/2 times a 3 over 2, which is a 3 over 4. So I get 3 pi over 4. Pi times 3 over 2 is 3 pi over 2. 3 times 3 on top is 9 pi, and 2 times 2 on the bottom is 4. And then the 2's cancel out, so this should be 3 pi. So if I go to graph this, and I'm going to sketch the parent function real quick. The parent function for cosine looks like that. And then if I graph mine, I have 0, 1. 3 pi over 4 is more than a half, so 3 pi over 4 is 0. 3 pi over 2, I'm at -1. This is equal to 2 pi and then a pi over 4. So here, that's not a full cycle. So if I go back here, You can see the difference between these every time there's a 3 pi over 4. So I can go backwards to 3 pi over 4 and go down. So I can graph my full cycle like that. There's my full cycle. So you can use these steps at the bottom to graph. And everything that's summarized in this table right here is the exact same thing that I pretty much do. Oh, it's horrible, sorry. It's the exact same thing I do when I'm making my table. So I prefer to make the table, but you can follow the textbook's method as well. So let's graph a couple more examples. So my theta, 0, pi over 2, pi, 3 pi over 2, 2 pi. It says sine, so I want the y values. 0, 1, 0, negative 1, 0. Okay. The first thing I want to deal with is the negative 2 out front. The negative 2 out front affects my y's by multiplying by a negative 2. 0, negative 2, 0, 2, 0. Then the 3 right here, that's the girl that's lying. So instead of multiplying by 3, you're going to divide by 3, which is the same thing as multiplying by a 1/3. So you get 0, pi over 6, pi over 3, pi over 2, and 2 pi over 3. So if I go to graph, 0, 0, pi over 6, negative pi over 2. So pi over 6 is right after 0, negative 2. Pi over 3 is just before 2 pi, and you're back at 0. Pi over 2 is, oh, hang on, that's not far enough over. Pi over 2 is at 2, and then 2 pi over 3 is back at 0. The dots on the x-axis don't have to be exact, but approximately, so there's one cycle right there. And if I were to ask you some questions about this one's amplitude is 2. Its period would be 2 pi over my b value. My b value was 3. If I asked you the range, this thing goes from negative 2 to 2. Just some food for thought. Okay, let's try the next one. The next one looks a little weird, but I promise it's not. So we're just going to keep doing the same process. Trust the process even if the numbers feel a little funny. So theta, 0, pi over 2, pi, 3 pi over 2, 2 pi. This is cosine. So remember, I want the x values. 1, 0, negative 1, 0, 1. Just go piece by piece. So first, multiply all your x, y things by a negative 3. Negative 3, 0, 3, 0, negative 3. This says to multiply by pi. That's lying. Divide by pi. So if we think for a second, 0 divided by 0 is 0. But just so you can see what happens, pi over 2 divided by pi, which is the same thing as pi over 1. You keep change flip. So pi over 2 times 1 over pi makes the pi's cancel out. You get a half. Pi divided by pi is 1. 3 pi over 2 divided by pi is going to make a 3 pi. Oh, not a 3 pi, just a 3. A 3 over 2, and then I'm going to get a 2. So this time on the x-axis, I'm going to use just the actual numbers, not the pi symbols, not the radians. So when I go graph this, 0, negative 3, a half, 0, so a half between 0 and 1. 1, you're up at 3. At 1.5, you are at 0. And at 2, you're back down at negative 3. Please don't draw this as a parabola. It is a sine wave. And if you notice, the distance from here to here is a distance of 2. So my period is too long. So watch this. If I'm down here, oops, that dot's not quite in the right place. If I'm down here, 2 later, I should be back down here again. Halfway in between those two, I should be all the way up. And then you can draw another period. Let's try again. So if I'm at 4, we know 2 later, I'll be all the way down. Halfway in between, I'll be all the way up. So there's another period. So you can draw more than one period if you need to in your homework. Okay, so let's work the other way now for example 6. Example 6 says determine the form for the graph. So before I do that, I need a couple things. If I was going to write a sign, the middle dot should be on the y-axis, because sine goes up and down. So it's this middle dot that's on the y-axis. But for cosine starts at the top of a hill and then it goes down and back up again. So when I go to this graph and I look at my y-axis, that is a low point. It's the bottom of a hill, which means because it's a hill, I'm going to write a cosine. So I know I'm going to write a cosine. Now I look at what they tell me. They say find an A and B. A is how high or low you go from the middle. So my middle was the x-axis. I go 2 up and down. Again, I go back to this black drawing. I should have had a maximum on the y-axis, but I don't. I have a minimum, which means it was reflected over. So it wasn't just a 2, it was a -2. And then to find my b value, I just need to do my period. So my period is how long it takes me to repeat myself. This is the bottom of a hill to the bottom of a hill. That green line I drew has a length of 4 pi. So 2 pi over b should equal my period. So 2 pi over b has to equal my length, my 4 pi, my period. Or 4 pi over 1. So you can do your bat and ball, or you can cross multiply. 2 pi should equal 4 pi b. Divide both sides by pi, and then divide by a 4. So you get 1/2, or 2 over 4. It's going to equal b. So I should have 1/2 x. So my equation should be y equals -2 cosine 1/2 x. Okay, and number 7, we're just going to interpret the model. So to interpret this, according to the model, back up. The average temperature in degrees Fahrenheit at Moodle Bay, Canada can be approximated by the function given, where x equals 1 corresponds to January, February is x equals 2, and so on. According to the model, what is the average temperature in the month of May? Well, May would be x equals 5. So I do 34, y equals 34, sine pi over 6, 5 minus 4.3. So when you type that in your calculator, you should get the answers about 12. And the time was in months, so about 12 months. What would be an approximate average temperature? The average temperature should be that plus C thing at the end, or it used to be in the front over here, C plus. That's the horizontal middle line that cuts that wave in half. Mine is +0. So the average temperature is 0 degrees Fahrenheit. And the range from the function uses the following. If I know my middle line is my C value, and then this is A, and this is A. From my middle C, I go up A and down A. A is 34, so a range from this graph would be I go from 0 down 34. So 0 minus 34 is -34. 0 plus 34 is a positive 34. So that should wrap up this section. And tomorrow, we'll practice some more transformations of sine and cosine on the next couple of pages.